So, good, we're back again. I guess we are complete now to start for the second part of today's, the second part of the presentation. And now we are talking about high quality application. Products, what products are existing to help your work, what is the difference between the different products available on the market, why have we chosen our products the way how it works, and how is our point of view about the tape connection, how does it perform, and all this is now the content of the coming hour, 1.5 hours, depending how fast we go through. When you take it in our assortment, or in assortment of every producer of airtightness materials, you see that they have tons of different solutions, tapes, and for realizing real airtightness, real airtight construction, when you're a good installer, you only need a tape, a glue, and a membrane. That's all. And then you can add some additional tapes for your help, some corner connection tapes, some grommets, or you need maybe a primer when you go into the refurbishment sector where you have a lot of dust, old materials which are not stable. Then you have to prime it. For a subwoof membrane, you need sometimes maybe a nail tightening tape. I'm not sure if you use it here in Latvia, but in Germany, Austria, Switzerland, it's a must. You're not allowed to use the subwoof membrane without a nail tightening tape. And I haven't used it in my time as a carpenter. And I thought in the beginning this is a crazy thing. It's absolutely unimportant to seal the nail penetrations of subwoof membrane. But when I talk to German roofers, they say everybody knows of one big damage they have found on the building site. But I come to all these products later. But if you take a look at a house building, realizing airtight, you have the membrane on one hand, and of course you have a lot of special connection materials to guarantee real airtightness. Good, this is what I said. You need a good, well-trained installer only needs a glue, a tape, and a membrane. So it's important as well that adhesives and membranes are always in the system. So of course we optimized our glues to the surface of our membranes. Some other producers do it the other way around. They try to optimize their tapes to other membranes and so on. So it's always good to stay in the membrane as well in case of a warranty. It's like a car. You're not buying a Mercedes layout and you're buying a Skoda engine and you're buying seats from Honda and whatever. So a car is always a system where all parts belong to each other, and only when you have a car which is tested and planned you can be sure if you, in any case, if you have any problems with the engine, that you get the warranty issues. And it's the same with airtightness membranes. So we offer a 10 years warranty when you use the whole system. If you have tapes, different tapes used on different membranes, you have always a discussion who's responsible for it. So if you're in the system, you can be sure that you have only one guy to talk to. Good, and then you can say, of course, adhesives and tapes, membranes are a system, and adhesives on the surface are a system. So most of the connections we are doing with tapes is not to the membrane itself, but it's to wood, to stone, to timber, to window frames, whatever. And of course, these tapes must be able to guarantee with these materials as well an airtight connection. Good. When we plan an airtight houses, the approach is very simple. We must be able, after the planning, to take a pen and draw one line without interruption around the house to be sure all of these surface has been is airtight. And the planning is very simple. When we have a masonry wall, we need to plaster the wall or add a membrane to it. It's not so common in Europe, but in the US, I'll show you later, to put plaster. Plaster is airtight, not the stones, with the motor between. Concrete is airtight, and if I have a timber construction, I have to cover it with an airtight material. This can be a membrane from ProClima, it can be an OSB board or a plywood board, whatever. But after the planning, I must be sure that the whole surface of the house is covered with an airtight material. And then so far so easy. But now the difficult part starts. And I have all these connection points between a massive wall and a timber roof, or I have penetrations of cables and pipes, or I have here a ceiling, a timber ceiling is lying between two timber walls, and I have the connection between a timber wall and the concrete floor. And all these connection points must be planned in advance airtight. Because if I'm not doing it, it can lead to situations on the building site where airtightness could not be realized by the hand workers, because it's impossible, or with an enormous amount of work and materials. So planning is clearly an important point. Yeah, the simplest connection is just the overlaps of boards, OSB boards, or a membrane. So we simply take a tape, and we seal the overlaps with this tape. And optimal is, of course, when we have a rigid surface, that we have a good pressure. But this is not, it's in the seldom cases possible. Normally we install the membrane the other way around, orthogonal to the carrier structure, and then we seal the overlaps in the orthogonal through the rafters. This is a common way to do it. Point. If we are working with blown-in insulation, it's important that the tape connection is covered with a lathing. Because blown-in insulation brings a lot of pressure in the component, and we have to support to keep the connection pressure-free. Because this construction must remain for the coming 50, 40 years airtight. Good. When we come to the tape question, it's always what comes up at once. Aren't all tapes the same? Because when we take a look at the tapes, they have different carrier material. They have plastic foils, they have paper, or they have a spunbond as we have. They have different color. They are white, blue, green, purple, whatever. And when we take a look at the glue, it's normally crystal clear. And then we take a look at the data sheet. And in the data sheet, all the data are similar. So they stick up from -10 degrees, they have temperature resistance from 40 to 100, they stick to all surfaces, then we came to the price. And the price can be very different. So we have very cheap tapes, and I would call them quality tapes, or tapes which are more expensive. But it's for us not clear to see the difference, and then we can do a test. And how does the test look like? This is a very common test. We just stick the sum to the glue, and then we say, oh, and depending if we have eaten döner to lunch or a burger, then the addition is not so good. So the sum test is very common. Or we just cut a piece of tape, we stick it to the ground, and then we tear with a strong force on it directly after installing it, and then we think, this tape is good, or this tape is not good. So there's not real difference. We do not see a real difference if we compare the different tapes with each other. But there is a clear difference. Most of the tapes are so-called, it's German, sorry for that, acrylic dispersion glues. This is, I guess, 95% of all the materials in the market. And who was good in geometry during school? Nobody. Me neither. Dispersion is something is solved into water, and this is how these tapes are produced. It's very simple. It's acrylic dispersion glue. So we have here the carrier material. It can be a foil, a paper, whatever, and then we bring a liquid on this carrier material. In this liquid, we have these acrylics. Acrylics are the main content of the glue later. Then we have normally resins in, but be careful. There are tapes available, acrylic dispersion tapes. They say we are resin free. Maybe they are, never tested it, but normally we have a big amount of resins in it. And we have emulgators in, the green dots, and a lot of water. The acrylic is later the crystal clear glue. Resins they put in to achieve a better connection to bad surfaces. You know resins from timber, I guess. Yeah? Resins, you know what it is? And resins, when you put your finger in, what does it do? And what does resins do when you wait 100 years? You have amber. It's get brittle. And you know it's getting hard. And this is what some of these resins do the same. They may get brittle. You are not really sure if they really get brittle or not, because of course we have good resins, they not get brittle. But you remember maybe these hooks you can stick on your tiles in the bathroom, which has this aggressive sticking glue on it. And it's holding very good, and you put the tile on it, but maybe after 7 years, they fall off. And when you take a look at the back side, the glue is turned yellow and it's getting hard. And this can be caused by resins, as an example. So we said, oh, we do not want to have any resins in our glue because they may get brittle. You can never be sure, and we do not want to work with any glues where you have materials in where you do not know how the durability is really. And then we have the emulgators in. And the emulgators are only responsible that you have a homogeneous dispersion. This means that you do not have the resins swimming above and the acrylics down, so that you have a good mixture. That's the work that the emulgators are responsible for. Okay, and then you put the dispersion on the carrier. It looks like this, white normally. This is how an acrylic dispersion looks like. And the second step is you drive it through a heat oven. And the oven is maybe 200 meters long or 50 meters long, whatever, and it's running through this oven in a slow speed, and so the water is evaporating. And what remains, and then it turns during the evaporation process, it's turning from white to crystal clear, as you know, the glues available on the tapes in the market. And what happens now, if the water is evaporated, the acrylics get in contact and they are creating long molecular change, and these molecular change, they create a strong bonding, and they are responsible for the stickiness. And of course you have the resins on the surface, which helps to make it more aggressive sticking, especially to low tension surfaces, maybe cheap PE foils. And you have the emulgators in, and the emulgators have no sense any longer. The only sense emulgators have to react with water. And this is what happens. During the drying process. So the H2O is evaporating, the content of the acrylics is getting closer and closer, and when they are getting in contact, they are creating a molecular change. Good. And then we have this crystal clear glue, which is sticking when you put it in the but they have a clear weak point. If this acrylic dispersion glues get in contact with water again, not the acrylic and not the resins are reacting with water, but the emulgators, which is still in. And they put some water around them and in the structure, and by this the adhesive strength to the surface is reduced. And this is the second point why we said we do not want to work with acrylic dispersion glues. On one hand, resins are in doubt of the H stability. There are some without resins, they say, as I said before, and you have the emulgators, and emulgators are reacting with water. And a tape which is reacting with water and losing its adhesive strength when it's getting in contact with water is not good on the building sites, because how many 100% dry sites do you know? None. So water is normal on the building site, and we do not want to work with the glue which is reacting with water.